In this activity, we created a simple blinking LED circuit. The positive leg of the LED is connected to pin 9, while the negative leg goes to GND with the resistor. The LED turns on and off repeatedly, showing how we can control digital outputs through programming. For this activity, the same circuit is used but with different code. The LED now fades in and out smoothly, showing how we can control brightness using PWM. It demonstrates how varying signal strength affects the LED's intensity. For this activity number 3, another LED is added while still using P9 and GND with resistor. The two LEDs blink alternately, showing how multiple outputs can be programmed in sequence. This helps us understand timing and coordination between different outputs. Activity number 4. A push button is connected. Its left foot goes to pin 2 and the rest goes to GND. When pressed, the LED lights up, showing how inputs can control outputs. It's a simple example of how sensors or switches can trigger actions in a circuit. For the last activity, a potentiometer is added. Its sides are connected to 5V and GND, and the middle pin to analog 0. Turning the knob changes the LED's brightness through analog input control. This shows how user input can adjust the behavior of electronic components in real time.
In this activity, the buzzer's negative leg is connected to GND while the positive leg is connected to pin 9. The button's right leg is connected to GND and the other leg is to pin 2. When the button is pressed, the buzzer beeps, showing how a simple button can control sound output. The buzzer remains connected to GND and pin 9. Just like in the first activity, here the Arduino plays a short melody using different tones. This demonstrates how we can generate musical sounds using program frequency. Using the same buzzer setup as before, the Arduino produces the SOS signal pattern: 3 short, 3 long, and 3 short beeps. These projects show how buzzers can be used for coded communication or emergency signal. For this activity, the light sensor's left leg is connected to 5V, while the right leg is connected to A0 with resistor going to GND. When the sensor does not detect light, the buzzer turns on and produces a sound. This demonstrates how sensors can make buzzer respond automatically to change in light. Here, the potentiometer outer legs are connected to 5V and GND, while the middle leg goes to A0. The buzzer still connects to pin 9 and GND. Turning the potentiometer changes the pitch of the buzzer, allowing manual control over the sound frequency.
The 7-segment display is connected from pins 2 to 8 representing segments A to G. The Arduino lights up the correct segments to form the number 3 on the display. These show how each segment can be programmed to create a specific number or character. For this activity, the same pins go to segments A to G. Then Arduino displays numbers 0 to 9 one after another, showing how digits can appear in sequence using program timing.
One challenge we encountered during the first part of the class was figuring out the phrases and instructions in the manual because we were not yet familiar with robotics. It took us time to understand how each part works. Another challenge was when some components, especially the LEDs, were not working properly, which made it harder for us to test our circuit. For this task, for my circuit diagram, I used 6 LEDs with the positive legs connected to pins 2 to 7, then through a resistor to ground. I also changed the wire and LED colors for easy identification. For this part, I will present the prompt we used to generate the Arduino code for our dancing light task. The lights turn on and off in sequence, creating a smooth dancing effect controlled by the Arduino, which shows how timing and coding can bring simple circuits to life. And this is the flow chart for our task 1 dancing light. For this task, I created a button-controlled alarm system. The buzzer's positive leg is connected to pin 9 and the negative to GND. The LED's positive leg goes to pin 8, then through a resistor to GND. For the button, the right side is connected to a resistor and GND, while the other side goes to pin 2. When the button is pressed, both the LED and the buzzer activate, forming a simple alarm system. And here's our prompt to generate the code. And as you can see, after releasing the button, both the LED and the buzzer will activate within 5 seconds. This is the flow chart for task 2. For this task, we enhance our project by adding a stop button. Before, the system would only stop after 5 seconds, but now we can press the button anytime to stop it early. We showed the Arduino code where we added a condition that detects if the button is pressed to stop the LED or buzzer. This enhancement made our project more interactive and user-controlled.
Task, we created a program that displays custom letters on a 7-segment display. It starts with a circuit diagram showing the connection of the display using the same pins as before. We then generated a prompt in AI to create the Arduino code that makes the display show the word hi followed by hello, with each letter appearing one after another. After uploading the code, the 7-segment display successfully formed the letters, showing how each segment lights up to create word. This task helped us better understand how to control and program a 7-segment display.
And for this task, this is the process flowchart. The challenges we encountered throughout the tasks were mainly because there were no guides for the codes or circuit arrangements. At first, it was quite difficult as I often work alone, making it even harder, and had to rely on trial and error, which took a lot of time. But thankfully, once I understood the flow and the coding, everything started to work smoothly. This robotics experience was truly enjoyable and filled with valuable lessons. Even though things did not always go perfectly, we never lose hope. Every problem we encountered became a guide and a stepping stone for us to learn and grow. Through this journey, we discovered that not everything can be taught by teachers because they are only our guides. It is up to us, the learners, to explore, discover, and find meaningful lessons throughout our own experiences. At first, we honestly thought this subject would be extremely difficult because of the many stories we heard from other students. But as time went by, we realized that it wasn't as scary as we imagined. We learned that not every student enjoys this kind of subject, but we're glad that we're among those who learn to appreciate and enjoy it. What we once thought would be boring and stressful actually turned into something exciting, engaging, and fun. We are really looking forward to more tasks and upcoming activities, especially those that involve the different components and challenges. We hope that the things we once feared and found hard will soon be replaced with excitement, curiosity, and genuine joy in learning. With each activity, we aim to grow not only in knowledge but also in creativity, teamwork, and confidence.
Yun! Video!
Ate, sa baba. Sa baba. Sunod na step. Nag-upload na po. Nakalagay na. Yung code, wait lang. Ilagay natin yung code natin sa kanila.